Hello, today we'll be looking at dividing polynomials. This will be a two-part series where in this video we will be looking at long division, and then in the next video, or part 2, we will be looking at what they call synthetic division. Both will get you the same answer. However, synthetic division works if you have some special properties about what is being divided. However, we will get into that in the second part. In this part, we will be looking at long division. With that, I have listed out two rules that will help us when solving long division while dividing polynomials. I wanted to mention them before working through a problem so that we are all thinking on the same page. And these steps will make sense as we get through problems, but I wanted to mention them out. So the first thing we're going to do is add in missing degrees. What this means, if you have, for example, x to the 5th minus 16, and you're dividing by x plus 2, for example, x to the 5th plus 16, and then divide it by x minus 2, for example. What you want to do is you want to make sure that you write out all of the missing degrees here. So we're going to write out x to the 4th, x to the 3rd, all the way down until we get to 16. And that's going to be x to the 5th plus 0 x to the 4th plus 0 x to the 3rd. And we're going to continue that till we get plus 16. And the reason why we want to do that is because when we actually divide the x minus 2 into this problem, it's going to help us as we walk through the steps. So that is the first rule that I would suggest that you do. And this way we will not miss any steps. The second thing we want to look at is to remove the number you're working with. So if you have this x to the 5th, when we get our answer up here, when we get our answer or quotient up at the top and we're doing our steps, we want to make sure that as we're working through this problem and going down, which again will make sense when we go through a problem, we completely eliminate this term. So if there was a 6x to the 5th, for example, when working down, we want to make sure that we completely eliminate the 6x to the 5th. And we want to do that by using that quotient up at the top. Dividing polynomials with long division is very similar to dividing a normal number. If you need a refresher on how to divide, I will link a video in the description below. However, for example, if you have 256 and you want to divide that by 4, you start with this number here. If you can't do anything with this number, you'll move to the next number. So 4 can go into 25. That's going to be 6 times. 6 times 4 is 24. We're going to do subtraction and then bring down the 1. And then we bring down the 6. And then we have 4. 4 into 16 goes in there 4 times. Similar to what we did here with trying to figure out if it goes into the first placement or second placement, how many times this number can go in there. We're going to multiply those numbers together to get us a value down here. We're going to do subtraction, and then we're going to find out what's left, or the remainder, and then we're going to keep working that problem. Long division with polynomials are exactly the same thing. So if you understand how to do that, then you'll understand how to do these. Okay, let's look at our first problem. Okay, in our first problem, we have x cubed plus 8x squared minus 29x plus 44, and that is going to be divided by x plus 11. Remembering our steps, we said step 1 was to write out all of the degrees. We have x cubed, we have an x squared, we have an x, and then we have no x. So we've satisfied part 1 in our suggestion and making sure that all of the degrees are written out. Next, we want to ensure that the coefficient out in front, when going through the problem, cancels out. So what do I mean by that? Right now, we have how many times does x go into x cubed is what you have to ask yourself. And if we multiply x squared, then we're going to get x cubed. In this case, there's a coefficient of 1, so we don't have to worry about it. We ask ourselves, how many times can x go into x cubed? And that's x squared times. So we're going to look to go above the x squared, and we're going to put that x squared right there. Now, similar to regular division, we're going to take this number up top and multiply it by what we're dividing. So x squared multiplied by x plus 11 is going to give us x cubed plus 11x squared. Now what we want to do is subtract to figure out what we have left. So we multiply each term by a negative, so this becomes a negative x cubed, and this becomes a negative 11x squared. And we do that subtraction. This cancels out, and that is exactly why you want to match the coefficients, because you're trying to cancel out the term that you're working with. And so that's just left with an 8x squared minus 11x squared, which is going to give us a negative 3x squared. And we have that negative 29x plus 44. That's what's left over. Okay, now what we want to do is find out how many times does x plus 11 go into negative 3x squared minus 29x plus 44. Again, we're only focusing right now on this portion right here. And so how many times can x go into negative 3x squared? Negative 3x times. Because if we multiply negative 3x by x, we're going to get negative 3x squared, which is perfect because when we do the subtraction step, we're going to be able to cancel out this negative 3x. 3x goes above the x portion of our equation, and now we do what we just did. We're going to take that negative 3x and multiply it by our x. So that's going to be negative 3x squared. And then we take our negative 3x, we multiply it by 11. So that's going to give us a negative 33x. All right, and now what we want to do is subtraction. Figure out what we have left. So with subtraction, we're multiplying each term by a negative. That's going to become a positive, and that's going to become a positive. And so with that, again, we're trying to cancel this out, so that's great. So we cancel that term out. And now we're left with a negative 29x plus 33x. We add those together, and we're going to get 4x plus 44, because that's what's left. We do the same thing. We see how many times does x go into 4x, and that is 4 times. So we're going to put that 4 in its right place up top, and we're going to multiply 4 by x plus 11 to see what we're left with. So in this case, we have the 4 times x, that's going to be 4x, and then 4 times 11 is 44. We do our subtraction, and we are left with 0. So there's no remainder, and that means that x plus 11 goes evenly into x cubed plus 8x squared minus 29x plus 44, and this is our answer, x squared minus 3x plus 4. All right, let's look at our next problem. All right, looking at our next problem, we have x to the 4th minus 16 divided by x squared plus 3x plus 1. So remembering what our first step is, it's to rewrite this with all of the degrees showing so we can understand what our steps are going to be. So if we write this with all of the degrees showing, we're going to get x to the 4th plus 0, x to the 3rd plus 0, x squared plus 0x minus 16. If we multiply 0 by something, it's going to be 0. If we were to simplify what we just wrote, that's going to get us back to the original problem of x to the 4th minus 16. And we're going to divide that by x squared plus 3x plus 1. We're doing this because as we are going through the problem and finding what's remaining, we want to ensure that we're capturing all of the values. So let's start with this first term right here, x to the fourth. So we ask ourselves, how many times can x squared go into x to the fourth? In this case, it's x squared, because x squared multiplied by x squared is x to the fourth. We're going to go above the x squared term here, because that's where we're going to start, and we know that we're going to put an x squared as our first value in our answer. So then we ask ourselves, x squared multiplied by x squared plus 3x plus 1 is going to give us x to the fourth plus 3x to the third plus x squared. Now what we want to do is subtract. So that's going to put a subtraction sign on all of these, and then we're going to just add these together. That's going to cancel out. That's going to give us a negative 3x cubed, and that's going to give us a minus x squared. Now you see why it's important to write out all of your degrees, because as you're going through the problem, you want to ensure that you're not missing any variable. Okay, next we ask ourselves, how many times can x squared go into negative 3x? And the answer is 3x times, because if we multiply a negative 3x multiplied by x squared, we are going to get negative 3x cubed. Now we multiplied this negative 3x by 3x, we're going to get a negative 9x squared, and then negative 3x plus 1 gives us a negative 3x. All right, now we're going to do our subtraction. So when we subtract this, this becomes a positive, this becomes a positive, and this becomes a positive. And then when we add these together, this cancels out. This gives us 8x squared. This gives us 3x plus 3x, and then we're left with minus 16. We do the next step. How many times does x squared go into 8x squared? And that is 8 times. So we're going to do a positive 8. And then 8 times x squared is going to be that 8x squared. 8 times 3x is going to be a positive 24x. And then we have 8 times 1, which is going to give us a positive 8. And now we do our subtraction. So this term cancels out. We do a positive 3x minus 24. That's going to be a negative 21x. And then we have a negative 16 minus 8, and that's going to give us a minus 24. So then we ask ourselves, how many times can x squared go into negative 21x? And the answer is 0, because now our degree of what's being divided is larger than what's remaining. So then this becomes our remainder and our final answer. If we rewrite this, we can say x squared minus 3x plus 8, and then plus negative 21x minus 24 divided by x squared plus 3x plus 1 is our final answer. Or you can rewrite this as x squared minus 3x plus 8 remainder negative 21x minus 24. and that's your answer. Here we have the quotient, or what's evenly being divided into, or what's being evenly divided, and then you have your remainder, which is what's not being evenly divided into and what's left over. And then when you add those together, that's going to be your answer. When you multiply your answer here by what's being divided here, you're going to get back, multiply these together, you're going to get back to your original. And that's the exact same thing you would do in a normal division problem. If you had 6 divided by 2, that's going to be equal to 3. If you do 2 times 3, that's going to give you back to your original value, which is 6. We're not doing anything special. We're not changing anything. All the same rules apply as regular long division, but now you're just applying them to polynomials. All right, let's look at one more example. All right, looking at our last problem, we have 9x plus 4 divided by 2x minus 5. We ask ourselves, can we expand this out any further? And the answer is no, because we have degree of 1, and then we have no x or no variable, so that's good. So then our next question is, how do we get 2x to equal 9x? And the answer is, if we divide by 2 and multiply by 9, so we get 9 halves. When we multiply the 9 halves by the 2x, we are going to be left with 9x, because our second rule states that we're trying to cancel out this term here, which means we need to get it to the exact same value. And that's how we do that in this case. And that's what we have. We have no x value here. So then we put this 9 over 2 over the value that doesn't have an x. When we do the multiplication, we do 9 halves multiplied by 2x. That's going to give us, again, 9x. And then we do a negative 5 multiplied by a 9 over 2, and we get 45 divided by 2. Now what we need to do is subtraction. So when we subtract these together, this cancels out, and we are left with 4 plus 45 over 2. To get common denominators, we do 4 by 2 over 2, and that's 8 over 2. If you need a refresher on how to add and subtract fractions, I'll link the video in the description below. But 8 over 2, 8 plus 45 is 53 over 2. And that's what we're left with. Now we have to ask ourselves, how do we get 2x minus 5 to 53 over 2? And the answer is we can't with what we're trying to do. We have a degree that's larger than what's remaining, and because of that, we are done with the problem. So the quotient is 9 over 2, and then our remainder is 53 over 2 divided by 2x minus 5. We can rewrite this as 9 over 2 plus 53 divided by 2 multiplied by 2x minus 5. And this is our answer. Again, we're following all of the same rules that we would with typical long division. However, following the 2 suggestions that we've talked about in the beginning of the video helps us maneuver through these problems with ease. Now you know how to do basic division when dividing polynomials together. In part 2, we will look at a special type of long division, or synthetic division, which in some cases could be a lot faster. So stay tuned for that. If you have any comments or questions, please write them in the comments below. If you enjoyed and learned something, please give this video a like, subscribe, and we'll see you next time.